All right, today we're going to talk about a huge idea in artificial intelligence. It's actually a pretty old idea, but it's making a massive comeback. We're talking about the quest to build something called a world model. And trust me, it's a concept that could literally change everything. Just think about this for a second. How do you know not to step in front of a moving car? You don't have to actually try it to know it's a bad idea, right? You can predict what's going to happen, you can simulate it, all inside your own head. Well, that superpower you have comes from what scientists call a small-scale model of reality that you carry around in your brain. It's like you're constantly running a simulation, letting you play out different scenarios, pick the best one, and react to the world in a much smarter and, frankly, safer way. And this, believe it or not, is exactly what the biggest labs in AI are scrambling to build for their machines. The dream is to give an AI its own little internal version of reality. Think of it like a computational snow globe. It can shake it up, see how the pieces fall, and use that understanding to make way better decisions out here in the real world. Okay, so let's get a clear definition here. What is a world model? Officially, it's an AI's internal map of its environment. But it's so much more than just a database of facts. It's about understanding relationships, cause and effect, the basic physics of how things work, all so it can simulate, predict, and plan what to do next. But here's the kicker. This idea, it's not new. Not at all. In fact, it's been on this wild roller coaster ride throughout the history of AI, with some of the smartest people in the field fighting for and against it. So get this, the story kicks off way back in 1943, when a psychologist first floated this idea of a mental model. AI folks in the 60s loved it and built simple systems that had models of like a world made of toy blocks. But they were super brittle, they couldn't handle the real world. So by the late 80s, the whole field pretty much gave up on them. It's only now, with the insane power of deep learning and LLMs, that the idea is back with a vengeance. And this quote right here from the legendary roboticist Rodney Brooks, this sums up the backlash perfectly. His point was basically, why bother building a complicated, clunky, and probably wrong internal model when you can just look at the actual world and react to it? For a long time, that was the winning argument. Okay, so that brings us to today. The idea is hot again, but it's kicked up this massive debate right at the heart of AI research. And the question everyone is asking is this: do these massive models, the ones we use every day, actually have a real, coherent world model tucked away inside all those layers of neurons? I mean, they can do some pretty wild stuff that makes you think they do, but what's really happening under the hood? Well, when researchers really start digging into it, the answers so far seems to be kind of disappointing. They're not finding a single consistent model. What they're finding is something they're calling a bag of heuristics. Basically, a messy jumble of thousands of little shortcuts and rules of thumb that often don't even agree with each other. This is where the old story of the blind men and the elephant is a perfect analogy. The goal, the dream, is to build an AI that sees the whole elephant, a complete, unified world model. But what we have now, it's more like an AI that's just touching different parts in the dark. One bit feels like a snake, another feels like a tree trunk. It has all these disconnected pieces of information, but it can't put them together to understand the whole animal. So you might be thinking, okay, but if these bags of tricks work, who cares? If it gets the job done, why do we need to build the whole elephant? Well, it turns out it matters a lot. And there was this brilliant experiment by researchers at Harvard and MIT that shows you exactly why. They trained a language model to do one thing: give perfect driving directions between any two spots in Manhattan. And you know what? It nailed it. Flawless results. It really looked like it had built a perfect mental map of the city. But it hadn't. So here's what they did. After the model got an A+ on giving directions, the researchers threw in a tiny little curveball. They randomly blocked just 1% of the streets. Now, a person with a map would just find a quick detour, no big deal. But the AI, its performance completely fell off a cliff. It couldn't adapt. And that's because it never learned a map. It just memorized a giant patchwork of routes. You change one tiny thing and the whole house of cards collapses. And that is why this is such a big deal. Building a real-world model isn't just some nerdy academic quest. It might be the key to solving AI's biggest problems. It could get rid of hallucinations by grounding the AI in a consistent reality. It could unlock real, logical reasoning. And, maybe most importantly, it could make these incredibly complex systems safer and easier for us to actually understand. This is the Holy Grail.
It's why every single major AI lab is pouring resources into cracking this. But here's the thing, nobody agrees on how to do it. The top minds in the field are placing completely different bets.
So, how are they trying to pull this off? Well, on one side, you've got labs like Google DeepMind and OpenAI. Their bet is basically more scale. They believe if you just feed a neural net enough rich data, video, 3D simulations, the whole shebang, a world model will eventually just sort of bubble up on its own. It'll spontaneously congeal. But then on the other side, you have thinkers like Jan LeCun at Meta, who say that's a dead end. He argues we need a totally new kind of AI architecture, one built from the ground up to provide the scaffolding for a real model to form. It's a classic debate, emergence versus engineering.
So, who's going to be right? Honestly, no one knows. It's a total toss-up. In this massive quest to build these computational snow globes, to give our machines a genuine slice of our reality, nobody has a crystal ball. This is one of the most exciting and wide-open questions in all of science right now.
And that leaves us with a big final question we all have to think about. The prize here is huge, maybe worth all the hype. But what does it mean for us? What happens when our machines stop just mimicking patterns and truly begin to model our world?